As we know from our previous studies, vectors play a really important role in physics, and many of our quantities are vectors, meaning that they have both a magnitude and a direction. One skill we'll need to use quite a bit in AP Physics is the ability to find vector components and sometimes the ability to add vectors. So starting out with finding vector components, if a problem gives you the magnitude and direction of a vector, we're going to use the sine and cosine functions to find the x and y components. For example, let's say that the problem tells you that an object's velocity is 15 meters per second at an angle of 125 degrees. That 125 degrees is, of course, measured in your standard way from the positive x-axis. And so to find the x, or the horizontal component, we want to use the cosine function. If I do 15 times the cosine of 125 degrees, I find that the x component of the velocity is negative 8.6 meters per second. Similarly, if I want to find the y component, I'm going to use the sine function. So that the y component of this velocity is 15 times the sine of 125 degrees, which gives me a y component of 12.3 meters per second. If you need a little more instruction as to why we're using sine or cosine as we are, please feel free to stop in and see me. Another skill that we'll use sometimes, not as often as finding components, but we will make use of this, is the ability to add vectors. The first step in adding vectors is to find the components, typically the x and y components, though sometimes, as we saw in honors physics, it's more useful to do things like components parallel to and perpendicular to a ramp. After we find the components, we're going to add the like components. So we would add the x components together and add the y components together. And then we'll find our resultant, the magnitude and direction of that final answer, by using the Pythagorean theorem and also some trig to find its angle. Now, something that's new in AP Physics that we haven't seen before is something called a unit vector. A unit vector is a vector that points in a particular direction, but its length is equal to 1. So when we multiply a unit vector times a number, it doesn't change that number, but it just gives it a direction. The most common unit vectors that we'll see throughout all of AP Physics are I hat, j hat, and k hat. Notice that they're called hat because they have a little hat on top of the symbol. And I hat points in the x direction, j hat points in the y direction, and k hat points in the z direction. So as you can see in my little diagram here, they're missing their hats. I stole this diagram from the internet. But the I hat vector has a length of 1 unit and points to the right. J hat has a length of 1 unit and points upward. And k hat has a length of 1 unit and points outward, or the positive z direction. These are useful because it's another way of writing vectors. We call it unit vector notation. So for example, I have written my position vector here, r, in unit vector notation by saying 3i hat plus 2.5 j hat minus 7 k hat, and that's in meters. You could choose to put the units on each number or use parentheses and put the units all the way at the end. One of the reasons unit vector notation is useful is because it makes adding and subtracting vectors significantly easier. It'll also be useful later on in our study of physics as we learn about some other operations we can do with vectors called the dot product and the cross product. We will, of course, apply these ideas of vectors, first kinematics, and then throughout all of our units beyond here.